This is John Staples, W6BM. In October '96, I went up to visit Al Jones in his Tube Museum in Crescent City, California. Al is the founder of the Tube Collectors Association and original editor of the Tube Collector, a small magazine that goes out to tube collectors and tube aficionados. Al was kind enough to give me a tour of his museum. Al?
Thank you very much, John. Thank you very much indeed. Well, here on this wall here we have some of the early postage stamps that were devoted to the early days of radio. And of course, this gentleman here, Mr. DeForest, he used to be my ideal when I was a young fella growing up. But now I'm a little older and a little smarter, and I find out that he, like myself, was somewhat of an experimenter just to get out and do things, but I didn't understand what the hell I was doing, and I find out later in life that he didn't either when he was doing his thing. Anyway, this collection of tubes here are mostly all Marconi tubes. There is one or two Oshrams, English tubes. A couple of these tubes came right out of BBC London, England. This MT9 here and MT6. These tubes are of the vintage of about the mid-20s to the mid-30s. They were popular. Some of these tubes I picked up here from the transatlantic communications link that Marconi had set up to Nova Scotia on the east coast of Canada. And then they had a Trans-Canada link to the west coast using these very same tubes in the late 1920s and 30s. And we're looking at this row of tubes here are some Heinz and Kaufman tubes from South San Francisco pre-World War II. For the most part, my entire tube collection concentrates on tubes 1935 and earlier. However, don't hold me to that because you're going to find some tubes that are unique or at least intriguing to me after 1935. But on this shelf here we have a lot of the HK 454 and 354s and what have you that were very, very popular amongst the hams prior to World War II and shortly thereafter in the early 40s. And this shelf and the one below it here, this is all Raytheon tubes, the RK transmitting series of tubes, which some of the RK Raytheon engineers told me there was only about 30 tubes given the RK prefix. The receiving tubes naturally did not have that, but so far I've collected over about 75 at least tubes that have the RK prefix, so I guess that engineer that worked there didn't know what he was talking about. And up on the top shelf we have some miscellaneous transmitting tubes and one Thiatron here from Philips Holland, a Westinghouse demonstrator tube to teach electron theory and an electronic emission, demonstrating cutoff and those parameters that tubes are subjected to in day-to-day operations. This particular row of tubes here is again more Heinz and Kaufman tubes, and including several prototypes that they built to get around the RCA DeForest patent rights that they had, and they were trying to have a monopoly in this line. They wouldn't let Collins Radio, Amperex, Heinz and Kaufman, or anybody manufacture tubes, and until finally they met Ralph Hines, and he fought them, and he's the only individual that ever won a court battle with Sarnoff of RCA over the patent litigations that they had. And they finally conceded, and they allowed Ralph Hines to manufacture all of the triodes of conventional design that he cared to. They gave him full licensing rights, and even ended up with a little bit of cash in their pocket as a result of that litigation. And it's quite an interesting story. If you care to learn more about it, why, read my article in the last edition of the AWA 10th Annual Review, which just came out this September. Miscellaneous photocells here, manufactured by Citron, General Electric, RCA, and what have you. Oh, it looks like there are probably 50 or 60 different types of photocells there. Miscellaneous counter tubes and what have you in this particular area, and a hodgepodge of Penta Laboratories tubes in this end. Miscellaneous early pentodes manufactured by IMAX, Sylvania, RCA, and what have you, the 4E27 series of tubes. Miscellaneous high-frequency RF components, namely used in radar applications, TR switches, spark gaps, and klystrons, some small klystrons and things of that nature in this tube. Some of the early tubes that was used for backscatter between Cuba and the United States a few years back, Cuba and Florida. Over here to this corner, we have a number of 50-watt tubes, the early 50-watt tubes, which really came out about 1921. These were popular with the hams, 203, 211, and 242s, 842s, from the very earliest of those tubes up through the last production, which are still being used, particularly by a lot of these nuts that are audiophiles that using these particular tubes in single-ended audio amplifiers these days and think they're great. I'm not going to say any more on that subject. Some X-ray rectifier tubes here, and up topside on each end of this cabinet is a couple of National Union radio rectifiers. In the center is a A and a B Federal Electric 100. And on the top side over here, if you can get up this, John, is some X-ray rectifier tubes up there, and an old radiola receiver, and a couple of 813s, one Marconi from England, which has a very, very nice bass on it. Sam and John here were looking at it earlier. It's got a beautifully polished chrome bass on it, which is the first tube that we've seen that had that beautiful a bass on it. Some more X-ray rectifiers as well as X-ray tubes here, and some older X-ray tubes here. These two shelves down here, John and I spent a little bit of time going through the tubes on that shelf. These are some of my unknown tubes. We've got them here. We don't know what they are, and we tried to identify them. I think that out of the tubes that you see on those two shelves, John helped me out with one that he was able to identify for me. And I also collect crystal holders. At the moment, I think I have about 167 different manufacturers of crystal holders, and some 200 and I think about 280 different crystal holders themselves. So about 180, 170 manufacturers and 200 and something different style crystal holders. And on this shelf here we have some TV video orthicons and things of that nature that John showed me some interest in, so he's going to take one home with him. I'm a ex-Apollo, North American Aviation, and I worked on the Apollo program for years. I headed up all of the avionics systems on the Apollo spacecraft, including some of the ground communications, navigation, guidance systems, and what have you. So we've got quite a few Apollo bits of membrana around the place here. On this shelf here is just some miscellaneous old-time equipment components, variable coupler, old carbon microphone, Ford spark coil that was used in a lot of the early transmitters. A few microphones up above. I got a lot more microphones in storage at another facility. This is a showcase that mostly has in it foreign receiving tubes. I'll say this, I started tube collecting in 1977, rather late in life, and I was initially collecting transmitting tubes only. That was my specialty. And after about 4 or 5 years of collecting transmitting tubes, going around to the flea market and visiting friends and what have you, I found it rather difficult to find new and different transmitting tubes. And lo and behold, a good friend of mine down in Australia, Finn Stewart, you may have heard the name. He's a famous Phillips tube collector. He had quite a collection of redundant tubes in his collection that he offered to me, well, for a few rubles. And I purchased them, and that gave me a kick in the butt with about 3,500 foreign receiving tubes, which got me started collecting foreign receiving tubes. And I did that because in the United States here, I find that very, very few collectors are collecting foreign receiving tubes. Majority of people interested in tubes in the state are using them on U.S. made receivers, U.S. tubes. So this gave me an idea to collect foreign receiving tubes, 1935 and earlier. This is just some of the tubes here. On this end over here are mostly tubes from Europe, the smaller countries over there, Yugoslavia, Czechoslovakia, and those nature of countries. In the center portion, there's a lot of Dutch tubes here from Netherlands, Holland, and English tubes. The English tubes here run over here to these series of Osram tubes in the boxes down at the bottom, and other English makes up to about this point. From this point on over, John, if you can get a little more light on there, is all German, early German tubes. We have some very early German tubes in there that are in the boxes, new in the boxes yet, that date back to World War I. Down at the bottom there are some of the 250 watt transmitting tubes, 204s, various models of it, 212s, lined up in the midsection. Out in the front here are some various manufacturers of the 852, the 860, and some signal lamps that were used in the German Navy. That's some of those lamps down there, and some of the very, very earliest of the 204s with a globe shape to them instead of the tubular-shaped glass. On this shelf here is a number of ionization gauges and some boxed early receiving tubes. And one tube in back here, which John was somewhat intrigued with earlier, is this CBS tube here, which is has a rotating disc on the inside with photosensitive paper on it, made by CBS. And this is the same tube, or a prototype of the tube that was used on the first lunar orbiter to take pictures of the lunar surface. We're very, very fortunate to have that tube along with several of the initial photographs that were transmitted back to the Earth here of images of the lunar surface. And in fact, the first lunar landing site by the Apollo mission was selected with some of those pictures long before they took later pictures of the surface. We have some Arcturus blue tubes here, and one tube that Arcturus made that didn't get too much attention. When the RCA came out with the metal tubes, there was a big demand for metal tubes, and the other manufacturers of tubes, glass tubes, were left holding the bag. Their tubes weren't just moving on the market. So Arcturus took some of their glass envelopes and put them inside metal containers, metal cases, and put this metal case, and they call them metal glass tubes, and that saved their butt for a year or so, and then later on they went into metal tubes as everyone else did. On the top side of this particular showcase, from here on over, is all very, very early DeForest transmitting and receiving tubes. The very, very popular H tube that DeForest sold to the hams, a 65 watt plate dissipation tube, which was very, very popular. And then his oscillons, the 250 watt oscillon and the 500 watt oscillon. And of course, when the popular 211 series, 203s and things like that came along, he even produced those, and they gave him either a 4 or a 5 prefix. So that's some of these tubes. And DV series of receiving tubes, some of the tubular metal containers that the DV3s, 4s, and 5s were sold in. And this section here has miscellaneous Marconi tubes and some other foreign receiving tubes, early tubes, including some French tubes. And on this end over here is mostly early RCA tubular audions and some of the early AC filament tubes that were made by Rogers and several companies in Canada. Oh, and in this box here, there's some of the Brightson blues and an old, looks like a laboratory prototype or university research lab transmitting tube here, unidentified. Really don't know what it is, but it's got some unique features inside as far as the construction of the plate and grids and things of that nature go. This little tube in this container here is made in Connecticut, and it's one of the early Myers tube, and it has the plate is nothing but cotton wound wire wrapped around the outside of the glass envelope. That's probably 1918, 1920, in that time period. Up here we have one of Dr. Zoll's transmitting tubes, radar transmitting tubes. This was classified had the highest classification during World War II of any radio component, and there's quite a history surrounding that tube and Dr. Zoll himself on how he left Germany, went to England, and brought the prototypes of this tube to the States, and then went with MIT and developed it, and it was produced in quantities just for the military during World War II by IMAC and one other company in Southern California. This tube with the copper elements on the inside here is a very interesting tube, one that played havoc with a lot of the radio amateurs in the late 1950s, 60s, and 70s. I'm sure that any radio hams out there that that are listening to this video would recognize this sound if I could bring it up on a receiver at the moment, but unfortunately it's off the air. This is the famous Woodpecker, the over-the-horizon radar pulse modulator tube. So that should give you people a feel what was creating that havoc that you listened to for so many years. Hi. A couple of small receiving tubes, another IMAC or Pentalabs. They both made this pulse modulator tube here for radar applications. Just a tube that's used in industrial applications here primarily. It's like the 450T that IMAC made, and these are just other manufacturers. This one here happens to be made by Maclet back in Connecticut. A Russian transmitting tube here. The Germans also made this particular style of tube. It's used in a lot of the low-frequency AM broadcast transmitters throughout the third world countries, even today. This tube is still in production in both Germany and in Russia, and possibly China, I don't know. But these tubes, there's still a pretty good size market for them with those countries, in those countries. All right, here we are in back of the showcase that we were originally talking to you about, its contents. Down here, which you can't see probably too well, is an early Dutch Philips transmitting tube, a 250 watt job. It's a little unique in its configuration. Up the top side here, we have the Japanese Navy's ship-to-shore shore station large transmitting tube. It's about a 300 watt plate dissipation tube. It's kind of unique in its design. It's got like two tubes in one with a common anode between them, and then the grids and screen grids are in parallel. This particular tube here performed the same service as did the Westinghouse and RCA 861 here, which I'm sure most of you fellows have seen around in great quantities at flea markets and such. This is used by the U.S. Navy in the same service that the Japanese tube up here did. Shore station installations and large battleships and things of that nature that could support that size transmitter in the early years. Along this lower window case here, we have a little bit of everything. An English rectifier tube here and miscellaneous American tubes here, including some of the early 250 watt triodes and rectifiers using the same glass envelope. This is about the only tube here that's unique. It's a Japanese version of the 861 Tetrode. Just shrunk down in size a little bit. I don't know what its dissipation is, but I would guess it's probably close to 200 watts or something in that nature. These Marconi tubes here, English Marconi tubes, they start out at about World War I time period and build up to about 1925. And they were used in various land stations to keep the British Commonwealth together in communications with their holdings throughout the world. And on the top side up around the corner is just some more X-ray rectifier tubes with a water-cooled X-ray tube on the top center here. Here you're looking at my ham station, what you can see of it. I don't have any modern gear with a lot of updated bells and whistles on it. I just use whatever I pull out of the warehouse and put on the bench here to operate. But we won't go into that. I'm sure most people are not interested and have seen this type of stuff before. Tubes is what we're here to talk about. Up on the wall here over the operating desk, we have a German transmitting tube on the end here. That's typical construction of a lot of German tubes. We'll see some more out with the large collection of German tubes that I'll show you a little later on. A couple of Marconi tubes here. Again, MT6, MT7s. Another Marconi, only these tubes here were made in England. Here's a Marconi tube made in Italy. Marconi had plants in Italy, United States, and England. Most of the tubes I have here are all English tubes. And the tube in the center here is a particular tube that I'm very, very interested in. I've written a couple of articles on them, and that's the Heinz and Kaufman tubes that are gridless gammatrons that they developed during the late 1930s to get around the DeForest patents. And this particular tube in the center here is a water-cooled tube, approximately 750 watts plate dissipation. There's no specifications on it that I've ever seen. There's only 2 of those tubes in existence that we know of. I've had both of them at one time, but now the second one of these tubes resides in the Manhattan College Tube Museum that Brother Pat Dowd has back there. The next 2 tubes to its left are French SFR tubes that were used in the communications net between the island of Madagascar and other stations throughout the world back in the late 30s and early 40s, up to just about World War II, I should say. And here on the end again, we have another Italian Marconi tube. And the tube to the left of that is a one-of-a-kind tube also. That's another Heinz and Kaufman tube to get around the RCA patent, transmitting tube, water-cooled. It has a unique construction of the plate on the inside in the grid. You can't see it from this angle, but you're looking at the back side of a plate that's kind of in a crescent shape. And vertical rods run up down the length of that anode. And these vertical rods are the grids, the control grids. Alrighty, now we get down to the other windowsill here, which just has a bunch of miscellaneous 250 watt American-made tubes, some Sylvania large rectifiers in back of the lamp there. Well, here we are back in. Over in this corner, we have in the top right-hand end here a couple of tubes that came from the island of Tasmania off Australia, that are used down there in the early years of the radio astronomy experiments. And what was that chap's name again?
Grote Reber.
Grote Reber, that's the gentleman's name. These came off of his radio astronomy facility. And I guess now that he's left Cornell, he's retired full-time now down there on the island and living with in his dream world of radio astronomy. This row of 4 tubes here, and I have a 5th one of this category of tubes. These are silica tubes, manufactured in England in the late teens and early 20s. And the silica glass was typical of ordinary everyday beach sand made into glass, and you can see the rough surface of the glass here. It was selected because it has a coefficient of expansion closest to the metal that they used down here to bring the metal through the seals into the tube. And in addition to that, it has a chrome alloy here as in a basket weave for the anodes for the plates. These particular tubes, transmitting tubes, they sold these tubes with a warranty and a guarantee that if the tube filament failed or any elements of it, you send the tube back to them, they cut it open with a diamond saw, pull the guts out and put a new filament in it or whatever it needs and ship it back to you for 50% of the original cost of this tube. Some of the companies in the States here tried these tubes on for a while to get around the DeForest patents also to buy foreign tubes. And they found out that as long as they used these tubes in the shipping trade, why, if they were in U.S. waters, why they still couldn't use these tubes for patent reasons. Up on the top side here, we have one of the original Fleming valves, diodes, on the left-hand side. And on the far right, a Manhattan diode, which is the American answer to the Fleming diode here. It came out about a year later. There's 2 or 3 versions of that Manhattan diode on the right. And the old AMRAD gaseous rectifier tube in the center there. Oh, the mercury vapor rectifier. Well, I didn't talk about the earlier, larger mercury vapor rectifier, but these mercury vapor rectifiers were used in the early 20s for the most part as high voltage rectifiers, and then in some instances low voltage rectifiers less than, say, 50, 60 volts. But this particular size tube made by General Electric was very, very popular with several of the hams in the early years. They jury-rigged these tubes up with a little jiggler to start them, and then some of them devised keep-alive circuits for them to keep the mercury in vapor so as that they could use them for CW applications and things of that nature. I want to talk a little bit about Heinz and Kaufman, Ralph Heinz in particular. He was, as I mentioned earlier, one of the individuals that really challenged Soronoff and the big RCA team back there regarding the DeForest patents that they had on the oscillator circuits, the regenerative circuits, and the triode tube as we know it, based upon the DeForest patents. Ralph was manufacturing transmitters and receivers for Globe Wireless, which was owned by Robert Dollar of Dollar Steamship Lines. And Robert Dollar played the whole Pacific Ocean from the United States West Coast here to Hawaii, China, Australia, and that part of the world. And he needed communications equipment to control and manage his fleet of ships. So Ralph Heinz was providing that necessary service through Globe Wireless and other names that they had over the years. But when Soronoff began threatening Heinz and Kaufman, or particularly Ralph, with possible litigation lawsuits, why Heinz didn't take it too lightly. He decided he'd run a whole bunch of studies here of the DeForest patents, the oscillator patents, the triode patents, and what have you, and see if there's a possibility of a way he could get around it, and or find out some way of disproving that the DeForest patent was a legal, legitimate first patent on the triode tube. So in time, he proved all of these things to not be legal in court. But in this process of getting to that point, he also manufactured common, ordinary, everyday triode transmitting tubes using the conventional designs based upon the DeForest scheme of things. But to get around that, he developed what he called the gridless Gamatron. The Gamatron name itself was given to gamma for the third element in his gridless Gamatron tube here. But you probably can't see it from where you're standing there, but the gridless Gamatron has two plates. One of them is a typical ordinary anode connected to the plate cap up here, and the other is the gamma plate, which is a little bit smaller in design, but vertically, and separated from the plate anode over here. Inside, the filament is very, very close to the gamma plate, or the control grid as it functions. This tube was designed by Ralph Hines as an exact replacement for the 204, which was popular in the 250 watt plate dissipation tubes used throughout the country, in fact, in most all medium power transmitting tubes. Well, this tube could be plugged right into any 204 socket, and you could carry right on with operations. It was a very, very rugged tube in its design. Its only downfall was that it had a mu of about 4. So it required almost as much drive as you would getting out of the tube. Didn't have much gain, but the tube worked. And so he produced this tube, and he used them in the dollar steamship lines, shore stations, and transmitting stations. This particular tube, as I said, was a copy to go into the 204s, but he found that he needed a little bit more power than what this tube could produce. So he produced a 500 watt version of it and a 750 watt version called the 255 and the 255H. The 255 was 500 watts plate dissipation. It has a plate that's only about 4 or 5 inches long here, and the 750 watt version is the exact same tube but a longer plate. This is a prototype of the 750 watt version of the HK255. The 750 watt version was called the 255H. They produced this tube in fairly good sized quantity, up in the hundreds, if you will, for use in Globe Wireless and ship-to-shore stations, including a lot of the larger ships, particularly the larger passenger ships throughout the Pacific. Well, later on, RCA in their litigation, they tried these tubes out in their labs back on the East Coast, and they couldn't make one of them work. They couldn't make it oscillate or anything, and so all of their experts said, hey, that tube won't work. But here Ralph Hines was using them daily, and he had court papers that he brought in with him showing how they were conducting normal routine service throughout the Pacific. In addition to that, they said that these wouldn't operate in a simple Simpson oscillator circuit and such, which he had demonstrating. Anyhow, when they finally got into court after about 2 or 3 years of on-again, off-again litigation, Ralph calls all of the RCA attorneys in for a little bit of a visit. And he had a bare room with nothing in it but except a couple of tables with these breadboards set up on it, demonstrating the use of all of these tubes and the various circuits that the Simpson oscillator circuits and other circuits that RCA said wouldn't work, and with or without these tubes. So he demonstrated to the attorneys and the technical people of RCA, showing these things, and then the next day they were going to go into court in L.A., or San Francisco rather. They show up in court, and first thing Ralph does is walk up to the judge and say, hey, I've got some boxes over here. I'd like to give you the key to the boxes and the locks on them. And he pulls out a great big Chinese key with a long handle on it, and he hands it to the judge. He says, these are models of all of my equipment demonstrating that these tubes do work, and we've got certified papers here from several operators that have used these in world communications, and I'm willing to take and demonstrate to the court these operational circuits, if you would so class. So here's the key. Call on me and I'll make the demonstrations. Well, immediately RCA attorneys called for a break in the proceedings. They went off into the back room for about 10 or 15 minutes, and pretty soon they came back to the judge and says, "Judge, we're withdrawing all of our litigation against Heinz and Kaufman here. We can't compete with this high technical background material that he has." And so after that, RCA gave all manufacturers full manufacturing rights of all of the patents that they were holding at the time and holding people up for. This affected Collins Radio, Amperex tube manufacturers, and several receiver manufacturers. Now they could produce tubes. They could take and produce receivers using the superheterodyne circuits and things of this nature. So this is one of the major contributions that Ralph Heinz made to the radio industry. Conventional triode tubes, typical construction inside that he developed. The tube over here in the center of the window is a Heinz & Kaufman 2054. It's a triode 2,000 watt plate dissipation tube, one of his largest tubes that he built. And they use this also at the Dollar steamship lines. This tube here happens to be another French SFR tube. Came from Madagascar. This is the 204 in an English Edwison configuration. And this is a triode English tube also that I would guess that to be about a 200 watt, 250 watt plate dissipation tube also. Hey, here we are at another bookshelf here that's displaying some tubes. In these particular shelves here we have several foreign tubes, receiving and transmitting tubes. Just looking at the very top of the bookshelf up here, here's a tune grid transmitter that I use on the air in the old time equipment contest that the AWA puts on 2 or 3 times a year. I have a lot of fun with that, with some old regenerative receivers, talking to as many as I can of the hams on the East Coast. In this area up top side here we have primarily Phillips tubes, transmitting tubes, big old rectifier tube here. On this bunch of tubes right here on this shelf, these are all various Russian tubes. Lots of these tubes are close copies of many American tubes. And outside a little later on, when we're showing you some of the German tubes, I'll show you a German tube which the Germans ruggedized our famous 807 transmitting tube. And this is a Russian copy of the German copy of our 807. We'll talk about that a little later on. And a Russian 813 and some miscellaneous other tubes here, including the little Acorn tube that like the 955, 956 here. This is a Russian copy of our Acorn tube. And this shelf here is mostly all Phillips transmitting tubes, medium to low power for the most part. I won't go into any detail, but they build a lot of tubes of unique construction. Here's a little receiving tubes here with the elements put in there on a 45-degree angle. You'll find quite a few tubes with the internal plate and what have you installed at a 45-degree angle. Why they did that, I have no idea. Unless they put them in an airplane, they were flying in a bank configuration all the time. And here we have some miscellaneous French and English receiving tubes. There's a few tubes in here also from some of the third world countries in Europe. Down on this shelf here, there's a bunch of Marconi tubes and Tungsram tubes from England, and Phillips miscellaneous small size transmitting tubes. Going down below, some rectifiers and Thiotrons. Some more rectifiers down below. This is a rectifier tube out of the famous 270 radar. That was the radar system that's first picked up the Japanese in their raid on Pearl Harbor. The transmitting tube equivalent to that is outside in another display I'll show you later on. And some more receiving tubes. These tubes here with this web coating are British tubes, British rectifier tubes actually, but they have an inert gas on the inside instead of being a vacuum, so they had to put this webbing over the outside of the glass in case they would break. Why these would be, being under pressure, would explode instead of imploding. And this is some more miscellaneous English, for the most part, receiving tubes, a couple of transmitting tubes in the back side I see there. Japanese tubes, I've got my Japanese tubes out in storage in another facility, but here's the Japanese equivalent to the 852. Some more receiving tubes. This is miscellaneous tubes. Here's a tube here from Hungary, from Italian tube, transmitting tubes. Italian rectifier tube, similar to this 866 Junior. Another Italian small transmitting tube here. A small French SFR tube. A couple of German and tubes from Hungary there. Let's see what else we got here. Poland. Some more Polish tubes. Got tubes from all over the country, and on the top side up here, these are more Japanese transmitting tubes up top side. This tube here is a little bit interesting. Excuse me. This tube is a copy of the DeForest Ocelon. The Japanese had a standing order in their embassy in Washington, D.C., beginning right after World War I, and they wanted copies of every tube that came off the production line manufactured by the American tube manufacturers. Well, they received copies of the DeForest Ocelon, the 250-watt version of it. It was shipped over there, and within 6 months they came out with this tube here, which is a copy of the DeForest Ocelon, except it has a carbon anode. This is one of the first tubes using carbon as a carbon anode. So this is quite unique in that sense. What you're looking at here is an Amperex 2200. This is a ZB series of the Amperex tubes, which is the largest glass envelope plate dissipation tube that was manufactured, to the best of my knowledge. It was used primarily in broadcast station transmitters as a Class B modulator tube. And here's an award I received from W1PU back in when I was living in Connecticut several years ago. I don't know if you people are familiar with the old Captain Kurt Carlson on the Flying Enterprise that sunk off the coast of England in the middle 50s. Well, that ship sunk, and he was a ham, and we kept in contact with him for about 2 weeks while the ship was sinking out from underneath him. And when he came back to the States after he lost the ship, why, we had a big celebration for him in Gloucester, Massachusetts, and this is one of the certificates of that event. And along the hallway in these bookcases, we primarily have some of the very early water-cooled transmitting tubes and other power tubes that were used, and some of them are still in service today, particularly in industrial applications. But we'll go through these rather fast. On the top side up here is a couple of water-cooled tubes, different versions of water-cooled tubes here, and some of the early air-cooled transmitting tubes, and down the bottom some more water-cooled tubes. Some more miscellaneous air-cooled tubes, and again small water-cooled tubes. One of the smallest water-cooled tubes that I have is about this size of tube here, this tube here, and including another kind of a small one down here which is unidentified. I have no idea what the type number, model number of this tube is. And we'll move along here. Some more tubes that are primarily used for rectifiers and industrial applications, manufacturing, plating plants, and things of that nature. Some early transmitting tubes here used primarily in medium power transmitter stations for AM, FM broadcast. And in fact, some of these tubes are run at reduced power in television applications. A Maclet tube down at the bottom there, which is a high frequency vacuum tube. I mentioned earlier outside that the 270 radar that witnessed the first of the Japanese aircraft attacking Pearl Harbor. This is the tube in the Westinghouse 270 radar that did that. And I showed you earlier the rectifier that provided the DC to that tube. And there's another rectifier tube in the back side that goes with that tube. I provided 2 of these tubes to the Westinghouse Museum, where they have rebuilt an old 270 radar and have it in service. Thomson transmitting tubes from France, a boiler evaporative cooling type tube. This tube here came out of Voice of America, and its companion vacuum cap there. 500,000 watts power, pair of those tubes. Synchronize the transmitters, and 1,000,000 watts output feeding the antenna with a high gain antenna on it, and hear it around the world, no problem. A couple of more small transmitting tubes here. One of these tubes came out of a FM station in Eureka down the road here, about 90 miles. That's it for here. John says I got to say something about this particular frame here. I was on the Apollo program and headed up instrumentation and some of the avionics, communications, navigation gear on that program. And both my wife and I, Nancy, she worked on the Apollo program as well. So I decided to put this particular group of badges, or whatever you want to call them, together, along with some of the awards. Well, now we've moved out to the second room here, which has some of my tubes displayed in it. And what you're looking at here, from this shelf here to the top side, are all German transmitting tubes. They date back to World War I on up through some of these tubes were used during World War II. But they're all very, very interesting to look at, from the mechanical design and their structure, and some of the internal tubes that they used. By tubes, I mean glass rods to support some of their elements and things of this nature. On this lower shelf down here, we have some of their high-frequency tubes primarily, and the low 3 NF tube, which is a 3 tubes in one. It was used in a lot of the early receivers that some of you German receiver buffs are quite familiar with. I'm sure this has been pretty well documented. But as I mentioned to John earlier, the Germans were taxed on how many tubes they had in their radios. And so to get around that high tax, Dr. Lowe invented this tube here, which has 3 triodes in this one glass element, and little hermetically sealed tubes down here with fixed resistors and capacitors in it, and all of the tunable controls to operate this receiver were external to the tube. And on this shelf down, we have a number of high-frequency tubes, and here is a 35-watt transmitting tube, World War I era, that Toby Deutschmann brought to this country. During the peak of World War I, if you can believe it, he brought about 17, I hear, to this country, and then marketed them through his store up in Boston, Massachusetts, the original Radio Shack store, and which was quite an interesting place for anybody that's been familiar with the early days of the Radio Shack in the Boston area. It was right close to Scully Square, where Sally Rand used to do her burlesque dancing. That made it attractive too. Amperex tubes. I'm sure all of you fellows are familiar with the Amperex company. And here we have a number of their manufactured transmitting tubes on the top side here. A few more special purpose tubes, including the famous 833 and other smaller tubes down here. Current day tubes, some of these are, by the way, not all very, very early tubes. And on the bottom shelf down here, we have a large air-cooled tube and another water-cooled tube here, air-cooled, another water-cooled Amperex tube at the bottom there. I can't say as there's any tube here that's really rare in its type and application, possibly this rectifier tube here is in its glass envelope configuration, a full wave rectifier with the filaments brought out on two big large lugs-like straps at the bottom. Otherwise, these tubes are similar to other manufacturers that were popular in the 1930s and that time period in general. Okay, this is the back side of the Amperex display that we showed you, and what I have on these two shelves here is another popular ham transmitting tube manufacturer, the Taylor Company back in Chicago. They manufactured probably, prior to World War II, one of the most popular lines of transmitting tubes for the amateur. Moderately priced, very, very good performance. And some of the tubes that you're probably familiar with is the T21 here, which is the old 6L6. They made two versions of it, a small and large glass envelope. The TZ40, the T20s and TZ20s, T50s, T60s. They even made a Cineglow lamp here for the early mechanical scanned TV systems. And the 862, 866 rather, and 866 Juniors you're familiar with. And they even made a Tungar type tube here, which I was quite surprised to find. I was not aware of the fact that they made any Tungar type rectifier tubes. And then the typical 800 series tubes they made, and a little higher powered tubes. And they even made an 808, which I was quite surprised to find. I've seen all kinds of General Electric and RCA 808s, but never a Taylor tube. In fact, this is the only one I've ever seen. And on the shelf below that, this is some of John's playthings. These are photomultipliers for the most part along this shelf here, and image orthicons. On this particular rack, we have all iMac tubes, and both sides, front and rear. And you're probably looking at, of the glass series of iMac tubes, one of the largest collection of the older iMac tubes in the country. I don't know of anybody that's quite got as thorough a collection as we have here. We consider ourselves very, very fortunate to have them. But on this shelf here is just some of the current type of tubes that were made up until, maybe 15 years ago or something like that, and maybe a few of them are still in production, but some of the smaller air-cooled ceramic tubes and air-cooled tubes for the most part. The 4PR1000, which is a pulse-rated 41000, which a lot of hams use in their linears these days, and the iMac 246 over here, which looks very much like the 41000. However, it's a pentode, if you can believe it, and so it requires much, much less drive than does the 41000, and this is called the X246. Although it is given an experimental numbering system, it was produced in limited quantities and used in special purpose transmitters in military applications primarily. And some of the early 204s, 304 TLs, and 227s and 327s that were used in radar applications in World War II. Here's another copy of the iMac 527, which was a pulse modulator tube and used in a lot of radar applications. Now we'll go around to the other side and we'll get into the more interesting iMac tubes that I'm sure a lot of you people are familiar with, that are as old as I am and a few of the other old codgers around the country. Okay, well, here we are on the other side of the iMac display. And I'll just run quickly through what we've got here. On the top side up here, the largest iMac tube, the 2000 watt plate dissipation tube, the iMac 2000T is in this particular tube here. The 750T, which is a little smaller tube, but not quite, still larger than the 1000T, which they did produce. That was, the 1000T was produced in fairly sizable quantity and was used in a lot of military gear. The an early 750T here was a tube that was originally designed by IMAC as a 500 watt plate dissipation tube, but it was very much over designed, and later on they upgraded it to 750 watts plate dissipation, and it was a very, very popular tube. The tube next to it here looks the same glass size, envelope size. However, this is the 1500T, and you can see it has additional cooling fins on the anode here, and a slightly different construction of the grid on the inside, a little huskier all the way around. Well, now we're moving on to the last tube on the top side here, which is an IMAC 1000T. This is a later version of the IMAC 1000. You can see a little huskier anode inside. In fact, you can see if this were in color, you could see the brown inside the glass envelope here. It's a highly used tube sometime in the past. Now we'll move on down here to the shelf below. And I'd like to start out showing you one of the very earliest of tubes manufactured by Bill Eitel and Jack McCullough. This is the 150T, which they advertised in QST and said that they had this tube ready to be marketed, when really all they had was a prototype that wasn't working when they first advertised it. But they knew, and they had confidence in themselves, they knew they could make this tube work, and they sure did. This is one of the early versions of the 150T, and you can tell by the cap on the side, on the top here, rather, plate cap. It's the full metal plate cap versus the later version of the same tube. And it doesn't have the cap over the top of the anode or the plate in there to trap any stray electrons. The little later version of the 150T. Then later on, for the large productions, they came out with the 250T and TH, TL series of tubes. And there are earlier versions of these also with the fins on the anode with a little plate cap. Then later on, they went to the more solid one-piece metal anodes or plates inside. And this is just the 450T and a small 100T there, which they produced after the 150T. And in the back side here, there's some more 300T, which is the first tube that was a 300 watt plate dissipation tube, which they manufactured initially as a custom order for a chap, Ham. He wanted to run a little bit more power, and he wanted a good, dependable tube, so he went to Bill Eitel and Jack McCullough and says, hey, design me and build me a tube for a little more power. Well, they came up with the 300T and the 500T. Later on, this 300T was so over-designed that it became the 450T, which everybody's familiar with. I'm sure they had the 450T, TH, and TL. And then the 500T, which I don't have. It's the only of the large early glass IMAC tubes. I don't have a 500T, but that later became the 750T for the same reason. It was highly, highly over-designed. And we have a prototype tube here of a pentode, which is an early experimental tube. The plate and grid connections are out the bottom as well as on the top side up here. That was an experimental tube used as a pentode, kind of like that 265 tube designed around the full 1000. This was an earlier version of that tube. The 450Ts, this is a unique one because look at the shape of the glass envelope here on the top side. This is the only 450T tube, and particularly one that IMAC made, that has that configuration. All of the rest of the IMAC tubes have the standard globular tube with the tubular top section. And the rest of the tubes along here are all standard tubes. They made a lot of rectifier tubes just by pulling the grid out of the 250 or the 450 triode tubes and use them as rectifier tubes. Here's a 450 rectifier tube here that was kind of the only tube I know of that size that didn't follow the typical IMAC tubular globular configuration. Here you're looking at some of IMAC's smaller glass production tubes that were quite popular before World War II and after World War II. A little SIM 1500 and the 15 rather, and the SIM rectifier tube here, a little 15-watt plate dissipation tubes, rectifier and transmitting tube used in HF systems for various military applications. IMAC had a contract with the Defense Department just before, right after computers came into being, when they were all loaded with thousands of tubes, the 6SN7 and such as that. Well, here is Project Tinkertoy, which was IMAC's design to get around a large heat generator and the 6SN7s in their computers that they had. It's a ceramic wafer type tube. And this tube was developed and in development testing when along came the solid state devices, which put this series of tubes right out of business in a hurry. So there's a few of these around the country, and I'm very fortunate to have one here as well. This one, by the way, was offered to me and given to me by Bill Orr, W6SAI. I'm sure most of you people know Bill. In fact, some of these tubes here, he gave me quite a bit of data on the history of them. And the 24 series, the IMAC 24, 24C tubes, 35T tubes here, different versions of them, 35TG as well. And the 75-watt tube, the early 75-watt tube began with the full metal cap on the plate cap on the top, open anode inside. And the 75T, and then they were up to the 100Ts, and a few special purpose tubes down there, like the 172s and things of that nature. And in the backside, some of the 3500Zs, 3400s, which most hams are very, very familiar with, and some of the tubes for high-frequency applications where they brought the grid out the sides of the glass envelopes for high-frequency transmitter applications. In the front, Dumont decided they were going to get into the transmitting tube business for a while, and they came up with this water-cooled version of a fairly high-frequency tube that they were going to use in some of their TV stations, which they shortly thereafter dropped and used conventional tubes of other manufacturers. In the backside here we have a Maclet water-cooled transmitting tube, approximately 50 kW, and another similar equipment tube here that was manufactured by General Electric, similar to this Maclet. Maclet, by the way, was later, about 3 years ago, bought out by IMAC, and then IMAC produced Maclet tubes for a short while, then they converted over to their own series of tubes. They only used those tubes for replacement of those on the market. The chrome-plated tubes just to the left of the Maclet are a couple of Tungsram tubes from England. Tungsram, a company in Europe, they had plants over the years in various countries, including Czechoslovakia, Yugoslavia, and some in England. Here are some water vapor-cooled tubes, but they actually use these tubes in an oil solution more so than water, and a water-cooled version in the back. Very, very pretty tubes, and I hope to set these up and display them properly sometime in the near future. This copper anode here is a copper anode from this Maclet 100, ML100 here. What happened was I brought the thing home and I was cleaning it up, and it blew up on me, so all I had left was the anode here, and I figured that's worthwhile just put out here for display, let people look inside the anode or whatever they want to do with it. And this is a I forget, this is a Philips, I think, water-cooled tube. that I picked up just a couple of months ago, about 2 months ago, I guess, and I haven't really researched that yet to get much data on it. And up on the shelf here, we have a couple of other water-cooled tubes, small ones. And this particular tube right here is a water-cooled tube that John has a little bit of background on. So, John, why don't you take the mic and tell people what they're looking at?
What this is an RCA tube that was used in their first 5 kilowatt television transmitter, the TT1. And this tube is a push-pull tetrode. What we're looking at here is underneath, and the filament and I think the screen and connections and everything on this tube is water cooled. You can see the water cooled connections there for the filament. You can see the water cooled connections there for I think the control grid. And then up above on top, it's got 2 plates. This is a push-pull tube, and you can see, if you, Ellen, if you would turn it a little bit, we can look in there and see where the water cooling passages are that for the plate circuit. And this tube is internally neutralized.
Water cooled passages are right here.
Right there. That's where the water goes in and out for each one of the plates. Right. This tube has automatic neutralization built into it. And if you see over there on the right-hand side, you see a little tab, and each plate is connected over through that little tab to the control grid on the other side. So this tube is internally neutralized. It's push-pull neutralized. There it is on the other side. So no external neutralization is required for this tube. Everything water-cooled. 5 kilowatt television final amplifier tube.
I want to show you probably the next to last display of tubes here, which is my Western Electric tube display case. On the top side, we have various popular tubes that they manufactured, the 279, the 212A, the 212D, and there's quite a few of the 212Ds used by some of the AMers on 160 meters these days. And so I'm sure you're all familiar with that. And one of the 241s, which was a Class B modulator tube, another 212D in the back side here. And on the shelves below, we have miscellaneous special purpose tubes that they built for many of their different types of communication systems. A lot of their telephone repeater applications, microwave systems applications, including some of their audio amplifier tubes used in theater audio systems, the 300, 350 A's and B's and what have you. And a lot of the special purpose trigger tubes and what have you used in ringer circuits for telephone applications. The famous 205 tubes, the 216s, and some of the other tennis ball tubes, as a lot of people call them. And let's see, then we have some of the first tubes that were used in scatter communications here by Western Electric, namely from small offshore islands to continental United States in the 30s for the most part in that time period. Some of the Western Electric peanut tubes, which you're all familiar with, and then the back side of that is the VT1, VT2 series of first contract tubes for the signal corps that most everyone is familiar with. Those tubes didn't last too long after they became surplus. A lot of the surplus companies were buying them up just to melt the gold out of the pins and the bases and then throwing the tubes away. So you find a lot of them with nothing, no solder, no gold or anything, and the pins in the bottom just sucked out. And let's see, down at the bottom here, again, primarily all voltage regulator tubes and special triodes and what have you for various communication systems at the Bell System, Western Electric, and produced by Bell Labs for the most part for special applications. Some of these tubes, they went through a very, very strenuous quality control system, and they picked out those tubes which weren't subject to internal changes in extreme climates, and they were used in a lot of the expedition works to the North and South Pole. and where they were exposed to extremely cold temperatures. The side of this Western Electric display, we have a few more of their tubes that are probably not seen by a lot of the people unless they're serious tube collectors. A little bit of everything: small, large tubes, special purpose receiving tubes here. Some in the back center there, there's some fairly high-powered transmitting tubes. Some tubes here with, for what reason, I don't know, they left the evacuation tip on the tube here, and it's an unbased tube. It's a 7931-2, whatever that is, and I have no idea. It's a tube that I've not found any data on. And some of the early 50 water tubes, they made quite a few tubes based around the 50 waters. The 211 is a major example, but here are some of the very, very earliest tubes around that tube. Look at the plate in it here. You can see it's this happens to be a 214, which I believe was a modulator tube for audio applications, and the construction inside looks almost like the same support structure that Amperex used for their tubes, but this, I believe, was 100% manufactured in the Western Electric plant. And there's some more transmitting tubes down here, probably anywhere from 50 watt plate dissipation up to 100 watts in the back side here. Nothing great and unusual. One of their early water-cooled tubes here that was used in that's about a 15 kW water-cooled tube. Some of the CRTs here, and some of the microwave amplifiers and oscillators on the lower side over here. That's about all I can say at the moment here about the Western Electric tubes. There's on the wall in the back of these, there's another larger Western Electric tube. Here we only have one Western Electric tube here, and this is a popular transmitter tube used in the AM broadcast industry for quite a while. As you can see, this tube here is unbased, and the base is off each end, and it looks like it's been used quite extensively, as the anode in here is all turned blue with usage. Above it, we have a Russian Svetlana tube here, one of their tetrodes that, although it's got the Svetlana label on it, that this was used for PR purposes. It's one of their old tubes that they pulled out of their warehouse just to make available to their marketing people for PR purposes. Over here we have another 500 watt plate dissipation Philips tube made in Holland. Again, this tube came from Tasmania at the Radio Astronomy Laboratory down there. And here we have a British VT. They use VT designations for their tubes as we do in the States here, but if you notice the British tubes, they sometimes have a hyphen, but very, very routinely in the VT designations. So if you see a tube without the hyphen in there, why generally you can assure yourself that it's a British tube. But this particular tube here is a tetrode, again about 200 watt plate dissipation, and used in numerous military applications. This particular one here was built for military use in their Navy over there. Wind up this little presentation today around this RCA 862 water-cooled transmitting tube. This tube was initially put into service about in 1922, but not too many of them were used at that year. Some of the first ones were used in the Empire State Building and a lot of their high-powered AM stations there. Then later on, they were universally used by radio stations throughout the United States and even in some foreign countries. But this is a 100 kW water-cooled transmitting tube, low frequencies. It's probably only good to about 2 kc or something of that nature. And it has a pretty husky filament in it. It operates at 30 volts at 205 amps. So, you know, it takes a good amount of energy just to light this bugger up. And this is one of the very, very earliest of the H62 water-cooled 100 kW tubes. This is a used tube, as you can see here, by the gray or brownish material on the inside of the glass. The tube I have outside in the shop is a brand new one. It was never put into service. And when I first spotted it to bring it home, it was in a wooden crate. The wooden crate was 3 foot square at the bottom, tapering into about 2 foot square at the top. It's a real rugged wooden crate with a door on hinges that opened up so you could look inside to inspect the tube. And for shock mounts on this tube, it was rather interesting. They had, this crate I was telling you about had 1/4 inch plywood on all 4 sides, and it was compressed so that it was in an arc like this on all 4 walls. And to that plywood, they had some webbing, which came over here to a metal plate that supports the tube, and that was only thing that supported the tube, except they had some bumper material on the top and bottom so as it wouldn't move too far. But it was a very, very interesting crate. I would have liked to have brought it home, but it just wouldn't fit in the Cadillac, so I had to bring the tube alone home. Oh, by the way, it might be interesting to note how I brought that tube home. I stuck it in the passenger seat in the Cadillac and wrapped it up in a blanket and taped it and tied it to the headrest and put it on the bottom of it down here on a big piece of sponge rubber, and had it all wrapped up in a blanket, and I put a straw hat on the top of it and drove all the way from Elgin, Illinois to California with it. Okay, John, well, that just about concludes our tour of the Ye Olde Transmitting Tube Museum. It's been an extreme pleasure having you with us, John, and I look forward to many, many more visits with you. Thanks a lot for dropping by.
Well, Al, thank you very much, and thank you very much for your hospitality. In fact, we did go back up in March '03 and took a few more pictures. You see a few of them at the beginning and the end of this video.